Here in 1.1, we're going to look at the basic elements of an election. So when they say basic, they really mean it. They're just going to count up ballots. It's not until 1.2 that you actually see any of the methods used for actually, or one of the methods used for actually trying to calculate a winner or come up with a ranking. And so the basic elements they want to look at first is you have the candidates, the voters, the ballots, and then different ways you could do this. So single choice is probably the kind of voting we're most familiar with. You just pick one choice, your favorite. But a preference ballot is where you get to rank. So maybe you have flavors of ice cream. You get to put your first, second, third, and fourth choices. Or a truncated preference ballot's the same thing. It would just be, say, if you got to put your top 3 ice cream choices and there were 100 to choose from or something. You're not ranking 1 through 100, you're just picking your top 3 out of maybe 100 different choices. When we're talking about people, the candidates, voters thing seems really obvious. Sometimes if you start talking about voting for different things, then you have to be careful who's the candidate, what's the thing you're actually voting for. Okay, then the outcome. You can say the winner only, or you could give a full ranking or a partial ranking. So who got first, second, third, fourth, fifth, so on and so on. And then a couple little things. The paradox, the more times you vote, the less you appreciate it. So maybe like internet surveys, they're always asking you to do tons of those. And so if you just can click off them, you usually do. And I know sometimes if I get one to read an article, I just click through the survey as fast as I can and don't pay any attention. So sometimes if you get asked to vote too many times, it feels like it means less each time. And then mathematically, in voting theory, so 2 parts. How do you set up the voting, and then how do you count the votes? And then they have an impossibility theorem that there's no perfect way to do it. So 1.2, we're going to look at plurality. It's just one possible method, and mainly what we'll look at in plurality is it's a simple method, but it's not a very good one. We'll just do one method and then look at tiebreakers and that type of thing, but there's no perfect one, and so that's why the section or the chapter has a lot of different methods. There's no one that does exactly what you want it to do as fairly as humanly possible. Okay, what we want to look at first though is a lot of times what they'll give you instead of the raw ballots is what's called a preference schedule. So they tell you how many people voted for each thing. And so in this one, it looks like they're voting for Mathematic Appreciation Society, the Tasmanian University chapter is holding an annual election for president. There are 4 candidates, A, B, C, D. It's convenient that their names start with A, B, C, D. And then there's 37 members of the club. And they put who they want first, second, third, fourth. So they must be doing like a president or something of this. So out of the ballot submitted, who should be the winner and why. So we're not going to figure out who should be the winner yet in this section, but we're going to look at the actual ballots and say how would we determine that. All right, so here's our ballots. And so everybody individually put their papers in, they pick their first, second, third, fourth choices. So if you look at this, it's a lot to look at once. It's really hard to determine a winner. And so what they want to do is just organize this information so that we can come up with something that looks a little bit better to say who's the winner. And so literally a preference schedule is somebody going through and just counting how many people voted each way. So let's, for example, we won't do them all here because they have them counted up on the next page, but we'll see how it works. So let's say I see a ballot right here, the second one, where they voted C, B, D, A. So what I want to do is count up how many people had that exact same ballot. Not just how many people put C first, but how many literally had C, B, D, A in that exact order. So here's one person had that ballot. Here's a second person with C, B, D, A. Here's a third one, fourth. Oh, and see, this one's a little different. It's CDBA, so I can't count them as part of this group. I'm just counting the ones that have the exact same CBDA ballot. So there's another one. There's another one. There's another one. You can count these a lot of different ways. You could go through each one and put a tally mark. I think it's helpful to count all the same ones at the same time. and then do something to cross them off. So the next time you count, you don't have to look at these ones again. They're already taken care of and you can see that. All right, let's make sure we got them all. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, then we had this one person who had CDBA, so that was different. So we do have to say, okay, there was one person who had a ballot that looked exactly like that. And then we could go through and do the same thing, like how many started with A. Full disclosure, these PowerPoints come from the book, and I know that this one has a typo, but it's not super easy to fix because I just have to erase one ballot out of it. So I think the number they meant to go with, because they said 37 voters, there's actually 19 ballots here, so somebody made a copy and pasting error. But mainly I just wanted you to see the process of when they give you a preference schedule, what are they doing? They're saying 11 people had this exact same looking ballot. We'll erase our stuff. Okay, so our ingredients. We have the people voting, which is supposed to be 37, but there were 39 ballots there on that other side, so maybe someone tried to sneak in an extra one. We'll have to figure out who was cheating in our fake scenario here. We have the candidates, so they're A, B, C, D, but it could be anything. So pizza toppings, colleges, and then our ballots. This one was a preference where they got to put who they thought should get first, second, third, fourth. And so here's what we were actually counting up earlier, is we know that, and this is what I was talking about them having one extra ballot in there, because we got 11 for this. We got 11 for this, and it was actually supposed to be 10, or they had extra ballots. We didn't count wrong. Okay, so what this means is that 10 people had a ballot that looked exactly like CBDA. Now, if we were trying to say, well, how many people voted for C first? You have to be careful. You can't just say it was 10 people, because see how this one person also put C first? So why aren't they grouped in here? Well, they had a different looking ballot. We're saying one person had a CDBA ballot, 10 people had a CBDA ballot, 8 people had ones that looked just like this, 4 people looked just like this, and 14 people put ABCD, put them right in order. So that's how to read a preference schedule. They're telling you how many people had each type of looking ballot. Okay, and then one other thing, they're talking about transitive property. When you see what they're talking about, it's a little self-explanatory, or it's probably what you would guess it would be. So what they're saying is, if somebody put CBDA, even though they didn't put, say, B first, we still know that they preferred B over D and B over A. So how do I know that? Or let's say if B wasn't a choice, how do I know who they would have picked? Well, it still preserves the order. So even if they like D third, I know that they still liked D less than C. This will come up in some homework problems where they have head-to-head matchups to break ties. So let's say if C and A were your only choice, it was head-to-head between C and A, how do I know who this person would have voted for? Well, I know that they would have put C first and A second if they were the only choices, because they put C over A. So if those were the only two choices, so here's an example of just having 2, but you could cut out 1, it preserves the order, so I know they would have put this first and this second if those were their only options, because they clearly liked C better than A. Okay, and then in 1.2, like I said, you get to actually figure out who's the winner and counting them up. But 1.1, just wanted to see how do elections work, and mainly how to read a preference schedule. There'll be quite a few homework problems where you have to rewrite a preference schedule.